So let's take the supervised machine learning. As I said, we're going to take them one by one, and then we explain each and every concept, right? So in the subsequent videos, we're actually going to take the algorithms, right? But there's some concept here that I want to make it clear right from the introduction, right? From the introduction here, so that as we progress, you will encounter them, but they will not be a new term to you, right? So if we take a supervised machine learning, what does a supervised machine learning means, right? Now, if you see this simple definition that I gave over here, right? I said that supervised machine learning is nothing. It's nothing but when the model gets trained on what? On a labeled data set, right? What do I mean by this labeled data set? What I'm saying is that if you have a model, if you want to build a model, right? If you want to build a model, and if you build this model on a data set, right? If you build this model on a data set that is labeled, right? That is what I mean by this supervised machine learning. If you build the model based on a data set that is labeled, then we call it a supervised machine learning problem. Now, what do I mean by labeled data set? What do I mean by that? What I mean by that is that let's take the example that we took earlier on, right? That we have a customer, right? Let's say we have customer A, right? Let's say let me actually take you to this, right? Let me take you here and then explain that to you. Now let's say that we have customer A, right? Let's say we have customer A. Now if a customer A is having attributes like let's say the age of the customer, right? Let's say the age of the customer. Let's say the gender, right? Let's say the gender of the customer. Okay, let's say the gender of the customer. Let's say the employment status, right? So let me do it that way. So let's say the employment status of the customer, right? Now, let's add one more, maybe educational level, right? Maybe educational level of the customer. Okay. So all these are attributes that you might be getting, right? All these are some attributes that you can have, right? Based on the customers that you have. Okay. So now if we have this, right? So all these are going to be attributes that you can have, right? All these are going to be attributes that you can have. So this is customer A, and maybe the customer A is somewhere 15 years, right? The customer A is say 15 years, and the customer A is say male, right? The customer A is say male. The person is unemployed, right? The person is unemployed, right? The person is unemployed, and then the education level may be up to say 10th grade or maybe 12th grade, right? Let's take it that way, right? Maybe up to 12th grade, okay? Now, let's say loan status, right? Let's take loan status. Okay. Now, in this case, right, let me give this so that you can actually differentiate. Okay. Now, let's say that this is a customer A, and based on this information of the customer, you did not give this person a loan. You did not give this person a loan. Let's take another customer B. Maybe this customer is say 31 years, right? This customer is 31 years, and this customer is say female, right? This customer is say female. This customer is employed, right? This customer is employed, and education level may be up to masters, right? Maybe this customer is having a master's degree, and then this customer applied for the loan, and then you granted. Okay, so you might be having several customers, right? You might be having several customers over here. Okay, you might be having several customers. Now, what happens is that in this particular case, you have this. This is what I refer to as the label, right? This is what I refer to as the label. Okay, label. Now you have either yes or no over here. This is the label that you have. So customer A is labeled as no, right? Customer A is labeled as no. Customer B is labeled as yes. Okay, so you have a label. You have a target to predict. Right, so if a new customer comes in, right? If a new customer comes in, let's say customer C comes in, right? Let's say customer C comes in, and then customer C is say let's take 21 years, right? The customer C is 21 years. Customer C is male. Customer C is a male. The customer C is employed, right? Customer C is employed. All right. The customer C is having say graduation or first degree, right? You can think of it that way, whether graduation or first degree, right? The customer A is having first degree. All right. Now, what we want to do is this one. What we want to achieve is to give a label to this customer, right? What label should we give to this customer? Okay, now based on human intuition, we can say that if we look at the previous customers that we have, right? If we look at these previous customers that we have, we can say that we should, let me undo this. Okay, just ignore about the color. I mean, I think the color just got messed up, but just ignore about the color. So what I'm saying is that we actually want to discover whether what label we should give to this customer. Okay, what label should we give to this customer? Now we can say that based on the previous experience that we have, right, based on these two customers, right, based on these two customers, we can see that this customer is a bit similar to this customer. Okay, the person is employed, right? The person is having a master's degree. The person is older, right? It's not young, like this one is 15 years, right? So this person got loan, right? This person got granted for the loan. So over here we can give it a label as yes, right? We can give this customer a label as yes. Okay, so that is the label that we want to predict. That's what we want to do. And if you have a data set already, which is containing labels, right, which containing labels like this, which you can base on these labels and then predict, then you're having a supervised machine learning problem. Right? You're having a supervised machine learning problem, which means that you have something to feed to your algorithm to supervise over, right? You can supervise over to see that whether your algorithm is actually going to make the right prediction or not. If it's not making the right prediction, you can go back and then readjust the model that you are building, okay? And then make sure that it performs very well, okay? Make sure that it's performing very well. So you supervise your algorithm to actually make the right prediction. So you can think of in that way, right? So if you have a label that you are trying to, or target that you're trying to predict, then you can refer to it as a supervised machine learning problem. All right. So let's go back to what we were discussing over here. So that's what I mean by labeled data sets, right? That's what I mean by that. And the example here also confirms what I was trying to explain to you, right? So if we say, if we take for instance, we have Apple here, right? We have Apple here. If we feed our computer with several apples, right? If we feed our computer with several apples, and then a new apple come in, right? A new shape comes. So if later on, maybe our computer has learned from this, right? So if later on a new shape comes in, right, that looks something like that, then our machine will say that, oh, this looks like something I have learned before, that I labeled it as apple. Right, so as you put in this data into the computer is going to label it as, say, apple. Okay, now if a new one comes in, then the computer will be saying that, okay, this one looks more like apple than it looks to say orange, right? This one looks more like apple, and I'm going to classify this as an apple. Okay, I'm going to classify this as an apple, right? And that's all that machine learning is actually going to do for us when we talk about supervised machine learning problem. Okay, so in this case, we have something to compare our incoming data with, right? We have a label to compare our incoming data with, and we can also label the new one that is coming in. Okay, so if something comes in which looks like this, right, which looks like this, then our machine will get to understand that, oh, I've learned something that looks similar to what you're giving me, and when I was learning it, I gave it a label as orange, right? I gave it a label as orange. Therefore, the new data that you're giving me is more like an orange, so I'm going to label it as an orange, right? I'm going to label it as an orange. All right, now there's a situation where you don't actually have any labels, right? You don't have any labels, you just have data points, right? You don't have any labels, you just have data points. In that case, what you might try to achieve is maybe you want to group customers according to maybe the behavior they do on your website, right? According to the behavior that they do on your website. Maybe some customers come to the website, and then you see that this customer buys say Apple phone, right? This customer buy Apple phone, right? The next time the customer comes again, the customer buys a MacBook charger, right? The customer buys a MacBook charger. Okay, now if there's another customer who also buy a MacBook Pro, right? Who also buy a MacBook Pro, right? If there's another customer who also is buying MacBook Pro, then you can see that this customer, right? Let's say this is customer A, this is customer B, right? Then you can see that, oh, these two customers are similar to each other, right? So I can group them together, right? So that later on I can recommend some product to them. So if a new iPhone comes, right, I can recommend that new iPhone to these guys because they are iPhone guys. They like iPhone products. They like Apple products. All right, so I can recommend that new iPhone brand to them. Okay, maybe there are some customers who also like Samsung product or OnePlus or other products, right? So if that case, right, I can group those who like Samsung products into another group, right? I can also group them into another group. So in this case, we see that we don't have a target where we are trying to predict, right? But we just have some similarities that we are actually trying to group them, right? So in this case, we call it clustering. We'll talk about clustering when we progress in the course. As we progress, we'll talk about clustering later on. Okay, so we cluster them according to groups, according to their similarities, and according to things that they do in common. On your website. Okay. That's another situation where you have unlabeled data, right? You don't have a target to actually make predictions. All right, so I think this is clear to you. So let's actually move on over here. Now this is a data set that I actually want to show you, right? This is a data set that I want to show you. So here you can see that we have no and then some yes over here. Okay, so this is a target. Now if you see this one, this is an attribute. So the job, we have the marital status, whether the person is married or not. We have the education level. We have default, whether the person has default before or not, right? We have their balance in the account, their house, and so based on this attribute, right, we can feed this attribute to the computer, right? And then the computer will actually figure out, right, based on this attribute, that there are customers who were married, who were having say primary education. We did not grant them a loan, right? So if a new customer comes in, when that the customer is also not married, or maybe the customer is married but having primary education, then I'm going to deny the person the loan. Okay, so the model will actually learn from the previous data that you're given, and then later on make predictions. Okay, make predictions. So in this case, we have something that we actually base on that to actually make future predictions. Okay, so make future predictions. So that's what I mean by supervised machine learning, where you have a target that you try to base on that target and then make predictions. Okay. Now let's see this simple function that you can actually see on your screen. So this is everything that I've been discussing over here. We have a target, right, where we call it y. So this y could be any label, right? It could be say no, right, or yes, right? It could be no or yes. So whether we should grant the person the loan or not, right? So this x could be the various attributes, right? It could be the various attributes, maybe the age, right? Maybe the age of the customer, maybe the educational level, right, of the customer, right? The educational level of the customer. It could be the marital status of the customer, right? It could be the marital status of the customer. So all these are some attributes that you feed to your algorithm. So you think of your algorithm as a function, right? That is actually going to work on these attributes, right? It's going to work on these attributes and then learn from these attributes. Then after that, later on, if a new one comes, right? If a new data point comes in, right? If we have a new customer that is coming in, right? If we have a new customer coming in with similar attributes, right? With similar age, right? That with similar age and similar educational background, with similar marital status, right? So with whatever information that they're coming with, right? If we feed it again to the same algorithm, right? We will be able to predict either yes or no, right? We will be able to predict either yes or no, right? So with that, we should grant this new customer a loan or not. All right, so that's basically what your algorithm is going to do. Learn from this already existing data, make predictions on the new data. Okay, make predictions on the new data. So that's basically what is going to happen here. We're going to see this when we talk about linear regression. We're going to see more of this in that particular class. Okay, so that's basically the summary of everything that you can see on your screen over here. All right. So as we progress, we're going to see how we are going to build the algorithm. So if we want to build the algorithm, what happens is that we actually save we divide our data sets. Okay, so let's say we have let me change this again. So let's say we have about 10,000 records, right? Or we have 10,000 records of our customers over here. Okay, we have 10,000 records of our customers. Now what happens is that I remember that I just show you the equation, right? Like y equals a function of s, right? So now this x, you can think of this x as this 10,000 records, right? That we're going to feed to our algorithm. So the algorithm will learn from this 10,000 records and that help us to predict either yes or no, right? Help us to predict either yes or no. So what happens is that if we are training our algorithm, we don't put all these 10,000 inside our algorithm for algorithm to learn from all these 10,000, right? So what happens is that we either divide our data set. Maybe in this case, we can actually divide it into, say, 7,000, right? Into, say, 7,000, and then we use, say, 3,000, right? We use 30,000 we use 7,000 to train, right? We use 7,000 to train our algorithm. Then we use 3,000 to test our algorithm to see how well it is doing, right? Because when you're training your algorithm, you might not have access to the new customer data to actually test it. So what will happen is that you reserve some part of your data so that you can use that one to test your algorithm, okay? So what you're going to actually do over here is that we use 7,000 to, I'm just giving a hypothetical numbers. It could be 8,000, 2,000, and then maybe 4,000, 6,000. So you can divide it in that way. What matters is that you use the majority, right? You use the majority over here, right? You use the majority to train, right? You use the majority to train, and then you use the minority to test, okay? Now in this case, right, in this case, we use the majority over here, which is 7,000, to train our data. Now, the data that we are using to train our algorithm is what we refer to as the training data set, okay? And the data that we are using to test our algorithm to see how well our algorithm is doing is what we refer to as the testing data set, okay? Now, we have the third part, right, which is called the validation data set. What happens is that, let's say you have the same example that I gave you. We have, say, 10,000 records, right? So we have 10,000 records, just like I gave you over here. All right, we have 10,000 records. Now, what happens is that if you want to train your algorithm, right, sometimes you might want to change some hyperparameters. We will talk about what hyperparameter mean, right? We will talk about that as we progress in the course, so you don't need to actually worry about that. What I mean is that there are some parameters in the algorithm that you can be changing by hand, right? You can change it by hand, right? So if you think of maybe the algorithm having, say, some parameters A and then B inside, right? Inside the algorithm, you can be changing this A. Maybe initially you say this A equals to, say, 7,000, right? And then this B equals 3,000. Later on, you can come and change it and say that this A equals 8,000, this B equals 2,000. So the parameters that you can change by hand are what we refer to as hyperparameters. We're going to see more of this, right? It's not, this is just a simple example for you to actually see. We're going to see more of that, right, as we progress. Let me just even show you something over here before I come back, right? Before I come back over here, let me show you something here, okay? So if you see this, right, this is a linear regression. So in the subsequent video, we're going to talk about linear regression, and we talk about this as we come to the lab over here, right? So if you see over here, if we go all the way down, right, before we started building our algorithm, right, you can see that I'm dividing my data set into training and then testing over here, right? You can see that I have X train, I have S test, I have Y train, I have Y test, right? And then I have I'm splitting this data, right? I'm splitting this data into training and then testing, right, over here, okay? I'll explain this line by line before even we get there. When we get to linear regression, right, I'll explain each and everything that is happening over here to you. Here, I'm just giving you an intuition that when we get the data set, we divide it. So in this case, you can see that I'm divided it into 70-30 ratio, right? I'm using 30 to test. That's why you can see test size over here to be 0.30. So this test size that you can find it in this function, right? You can find it in this function. It's a hyperparameter, right? It's a hyperparameter. It's a hyperparameter that we can actually change later on if we don't actually like it. All right. And this 70-30, right? It's not like you just go into the data set and then you select 70 and then you select 30, right? It's going to happen randomly. I'm going to talk about this random in a minute as we progress. And I'll come back here and you actually have an intuition about what this means. Right now, let's concern ourselves with this. All right. So what I'm doing is that I'm going to divide my data set. I'm going to use 70%, right, for training. I'm using 70% for training. Then I'm using 30%, right, for testing. Okay. I'm using 30% for testing. That is what is actually happening over here. Okay, that's why I'm telling you over here. That's why I'm actually giving you an intuition over here, so that when we get there, it won't be a new thing to you. That when we have our data set, we actually divide it into training and then testing set. Okay, so we use some part for training, right? Then we use some part for testing. All right, we use some part for training and some part for testing. Now, with this one that I was explaining before I went to the lab, right? What I mean by validation set is that maybe we have the 10,000 record, right? We have the 10,000 record as we discussed earlier on, right? So we have our 10,000 records. What happens is that I can also instead of using 7,000, right, for training, right? Instead of using 7,000 for training and then 3,000, right, reserving 3,000 for testing. What I can do is to maybe use say 5,000 for training, right? I can use 5,000 for training. Okay, I can use 5,000 for training. Then I can use say 2,000, right? I can use say 2,000. I can reserve 2,000. Right, I can reserve 2,000 for testing. Then what happens is that I can reserve the rest of the 3,000. I can use the rest of the 3,000 for validation. Now, what I mean by this validation is that anytime that I build the algorithm, right? Anytime that I build the model, to be precise, right? Anytime that I build the model, I'm going to test it as I move on, right? As I build the algorithm, I'm going to test it alongside, right? I'm going to test it. So I build, I test, I go back, I change it, right? I change the hyperparameters, then I test again to see the performance, whether it's increasing or it's going down. I mean, how I'm supposed to adjust it to make it better. So after I massage my data set, after I change all the hyperparameters and make it work better for me, right? After I've done all that and I see that things are working better for me, my accuracy is actually increasing, right? Maybe at first when I did it and I tested, right? Maybe at first as my data, my algorithm learned from this 5,000 and I checked the score of my model, maybe it was around 60%, right? Then I go back and then change some things, right? I go back and change some hyperparameters. Then maybe my accuracy increased to say 75%, right? It increased to 75%. Then I go back and change again. Then I come back and test again, right? I use the validation data set to validate it, right? Then maybe now I'm getting somewhere say 92%. So now I think my algorithm is now doing better. Now, don't forget that as I do the testing over and over again, right, or the validation over and over again using the validation set, right, my algorithm will also start to perform good on the validation. Now, in order to confirm this, that's when the testing data will come in. Okay, so now I've reserved this testing data, right, which is the 2,000 that I'm talking about. I reserve this, and this my machine will never see this, right? But my machine is going to be seeing this, right? I'm going to use this data to validate over and over again. I'm letting my machine to learn from this 5,000, and I'm going to use this 3,000 to validate it over and over again, so I see a better accuracy, right? Then finally, I'll be using this 2,000 that I reserved to test it finally to see whether to reconfirm this what my validation is doing, whether it's doing well or not. Okay, so I can also do that, divide it into three: one for training, one for validation, one for testing, right? Or I can just divide it into two: one for training and then one for validation. All right, so I can also do that. So these are some of the things that it will come in handy as we progress, right? So that's why I want to introduce you to it right from the beginning. Now, I just talk about how we are going to actually divide our data set into say 70% for training, right? 70% for training, okay, 70% for training, and then 30%, all right, 30% for testing, all right, 30% for testing. Now, what is happening over here is that this 70% that I'm talking about and this 30% that I'm talking about, we don't have a specific 70% to take. We don't have a specific 30% to select. Okay, what happens is that we select all these randomly. We pick all these data sets randomly. So if we will talk about this cross validation later on, right? But and then this fold over here. So just ignore this one for a moment. All right, and let's talk about this. So let's say that this is the data point that you have. Okay, this is the data point that you have. So let me pick this one and then. So let's say that this is the data point that you have. Okay, you have this is your data point all the way to here. Okay, that's what you have. Now what is happening here is that I'm going to select some, right, randomly. I'm going to pick this part of the data, right, for testing. Then the remaining, right, here, right, all these here, right, all this remaining here, I'm going to use it for training. Okay, And this is not that I pick the first items for testing, then the remaining will be for training, right? No, it doesn't happen that way. It could be random. I could pick maybe 2 from here, I could pick another 2 from here, right? Or maybe I could leave everything and come and pick the last 4, or I could pick it from somewhere in the middle. So if we see the second one here, you can see that the testing is being picked from here, right? While this one will combine with this one to be the training, right? Or maybe it could be somewhere here, right? I mean, all these are going to be randomly, right? All these are going to be picked randomly. And in each time that you run your code, right, it's actually going to do this randomly if you don't set any random seed. That's why over here, if you see in the code, right, if you see in the code, when we come to the linear regression, we talk more about this, right? So that's why over here you can see that I'm writing random state equals 1, right? So I'm just setting a seed so that if I run it for the first time, the random numbers that I will get that will store for 70%, right? The 70% data that I will get, right, will be the same random numbers that will go into the 70%, and the same 30% that I will get for testing will be the same testing 30% that will still go into the testing each time that I run this notebook. Okay, that's why I'm setting a seed here, right? Random seed here, so that although this is going to be picked randomly, but if you picked it randomly for the first time, right, I want the same random numbers over and over again, right? So the first time that I picked these random numbers, I want it to be the same random numbers happening over and over again as many times that I run this notebook, right? I still want the same random numbers. That's why I'm setting random state here. So when we get to the linear regression class, you get to understand this better. All right. So basically, that's what happens here. And I use this train test split, right, which I'll talk about when we're talking about linear regression. So you can see that I have train underscore test underscore split, right? That's what I'm using to split my data. So my data, I have 1, I have my X, and then I have my target here, right, which you will see the particular data set, and you get to know the X that I'm talking about. You get to know the Y, right? I'm going to explain this line by line to you to understand it. Okay. So now let's go back to what we were talking about over here. Let's go back here. Okay. Now, if you build the model, there are some situations that you might come into contact with. You might end up in 3 situations, right? Whether your model is performing so well, or your model is not even trying to perform well, or your model is performing as you want it to perform. Okay, as you expect it to perform. Okay, now if we see what you can see over here on your screen, we have this part which is called the underfitting. We have this part which is called the overfitting, and then the balanced. So let's take time and then explain what each means, right? Now, if you build your model, right, there are several things that you do to get the better, to get better accuracy, and we're going to see that as we progress. Okay. If your model is not able to perform well, right, on the training data, right, obviously if I give you if I give you a training, I expect you to perform very well when I give you a test, right? If I give you a training, I expect you, in the normal classroom, a teacher will come to the class and then give you a lectures, and then at the end of the semester, the teacher is expecting you to perform well, right? It's expecting you to perform well. But if you perform so well, right, if you score 100 over 100, it becomes suspicious that maybe the teacher has given you the question paper before, or maybe you saw the question paper somewhere, on his laptop or something like that. That's why you're able to perform so well. That's why you're able to score 100%. Okay. In that case, if you link that scenario to machine learning, right, we refer to that as overfitting, right? It is trying to fit everything, try to capture each and every point that you have in your data. So think of the blue line as the algorithm, right, that you have built. Your algorithm is trying to capture each and every data point that you have in your system, right? And that's not what we want. Now, however, if the teacher gives you the question, right, and then you end up performing so poorly, right, you perform so poorly, what happens is that we can assume that you did not even learn it. You did not learn anything that he taught you. You did not even go through the notes. You did not do any research about it, right? You just came and write it. Or maybe the mind itself, maybe you're having some kind of trouble, so you couldn't even do it, okay? In that case, we say that if you link that to machine learning, then we are saying that your model is underfitting. It's not even able to learn, based on the training data that you're giving to it, right? It's not even able to learn on the training data. Okay, now if your algorithm is able to learn so well on the training data, then we refer to that as overfitting, right? It's trying to overfit. But if your algorithm is not even able to learn on the training data, then we refer to that as underfitting. What we want is an algorithm or a model, right, that can do a better, right, that can generalize, right, that can generalize basically, right. Let me write it up here, right. So what we want is we want an algorithm that can generalize and production, right. So if we take the algorithm into production, it should also it should work well with new data set that will come in. Okay, it should be balanced. So over here you can see that although it's fitting in between the data points, right, most of the data points are lying closer to it, right, as compared to this one where we have some data points far away from the model, right. If we have the data points far away from the model, but you can see over here that it's trying to capture as much data points as possible, right, not trying to over impress as this one is doing, trying to capture each and every data point over here, trying to over impress us. This one becomes overfitting, this one becomes underfitting. This is the model that we want, right, to be able to capture as much data points as possible, so that when we have new data points, right, to come in, that data point can actually be captured as normal as possible. Okay, so what we want is a balanced model, a model that can generalize in production, a model that can do well when we take it out there. Okay, not the one that will not even perform on the data that it has seen before. All right, so if I give you the question paper before you come to the exam, obviously I expect you to score maybe 98 or 100%. Okay, so if you have seen the data, right, if you have seen the data and you're still scoring say 20%, right, then we see that, oh, you did not even learn from the question paper that I gave you. You did not learn from the data that I feed to the model. Okay, so that becomes an underfitting. Okay, however, if it is scoring so much, say 100%, then you can suspect it. But if somewhere 95, 98, right, just something like that, right, 85, 82, something like that, now you can see that your model is actually doing well, right, your model is actually doing well, right, somewhere 92, 95, 98, right, something like that. But if you have 100% a perfect model, then you can see that your model was underfitting, right, it was actually underfitted. Overfitting, right? It's actually overfitting. But if it's performing poorly, right, 20%, 15%, 30%, you can see that your model is actually underfitting. Okay, it's not even doing well on the training data itself, let alone talking about the testing data. All right, so that's some of the situation that you might encounter. We're going to talk about this more as we progress in the course, and as we encounter this situation, right? As we build algorithm, we might end up in one of these, right? We might end up in one of these, right? We might end up in one of these, and we will discuss it as we build the various algorithms in the class. All right, so let's progress from here, right? Let's progress from here, and then talk about this dependent and independent. Okay, so in your class we are actually going to be discussing this. So if you see here, right, before I even divided the data, before I start building the model, right, before I start fitting the model, you can see over here, right, you can see over here that I am dividing the data set, right, into independent variables and independent variables. That's why I want to introduce you to that concept. So everything that I'm telling you up till now, right, are things that we're going to encounter over and over again, and that's why I'm introducing you to right from the introduction class, so that as we move on, because in the next video we will start with linear regression, and we're going to start building algorithms straight away. Okay, so that's why I'm introducing you to these concepts, so that you actually get familiar with as we progress. Okay, let's talk about this dependent and independent variable. Let's go to the whiteboard, and then let me show you from here. Okay, let me show you from here. Maybe I should give a new one over here, right, so that things will become clear for you. Okay, so now let's take, for instance, let's just take maybe the GDP of a country, right? Let's take the GDP of a country. Okay, now if we talk about the GDP of a country, right, maybe we can list some of the factors that contribute to the GDP of a country, right? So I'm just going to take some hypothetical factors that can contribute to the GDP of a country, right? Okay, so let me just take, say, maybe the workforce, right? Maybe the workforce of the country, right? We can also add maybe the infrastructure, right? We can add the infrastructure of the country, right? Let me shift this one here, right? So maybe the infrastructure of the country, maybe the productivity, right? Maybe the productivity. So we can say the productivity, of the labor force, right? The productivity of the labor force, right? And maybe we can add the various innovations, right, of the country, right? So all these can contribute to the GDP of the country, right? All these can contribute to the GDP of the country. Okay. Now, what happens is that for us to get this GDP, right? For us to get this GDP, what happens is that we have to combine all these factors, right? We have to, so the GDP is actually depending on these factors, right? It's depending on all these factors. Okay, it's actually depending on all these factors. Okay, so based on what is going on in these factors, right? That's what's going to give us our final GDP over here. Okay, so GDP is dependent on all these, right? GDP is dependent on all this, but these ones don't depend on this, right? But GDP is dependent on all these factors to actually help us determine the final GDP of the country. Okay, now for this GDP, depending on these variables to for us to be able to determine the GDP of the final GDP of the country, right? We refer this GDP as what? Dependent variable, right? It becomes a dependent variable. Okay, it becomes a dependent variable because it's depending on these, right? It's actually depending on these factors, right? It's depending on these factors. And these factors that are not actually depending on the GDP, right? They are not dependent on the GDP. Okay, so and yeah, the workforce is not dependent on the infrastructure, right? And it's not dependent on the productivity or maybe the innovations. Maybe it can contribute to it, but as it stands now, right, we are not doing it in that way. The only thing that is dependent on these attributes is the GDP, right? All these are contributing to the GDP. So GDP is dependent on what happens in this, right? That's why GDP becomes our dependent variable, and all these becomes our independent variables, right? All these becomes our independent variables. Okay, all these becomes our independent variables. Okay, so you're going to see this over and over again. Okay, so let me go to the lab and then show you what I mean by that. Okay, so over here, if you see this data set, right, now what we are going to do over here, right, what we're going to do over here is to predict this MPG, right? We're going to predict this MPG of a car, right? So we're going to base on these attributes, all these attributes. Right, we're going to base on this attribute to make a prediction of that. So you can think of MPG. You can think of MPG equals, right, these attributes. So maybe cylinder, right, cylinder plus displacement plus horsepower plus weight plus acceleration plus model year plus origin plus origin Asia, origin America, origin Europe. So all of these, right, all of these are contributing to this. So MPG is dependent on this. So MPG becomes our dependent variable. So if you can see over here, dependent variable over here, we are selecting only MPG, and the rest of them, right, after we drop only the MPG, right, and maybe the origin, right, we store everything in X, which becomes our independent variable. We will talk about this in the next video when we talk about linear regression, right? We're going to discuss this particular lab session, right? You're going to discuss this. Okay, so that's basically what we are going to use this concept over here for, and that's why I wanted to introduce you to right from the beginning. Okay, right from the beginning. So in the next class, right, we're actually going to start taking each of the algorithms under supervised machine learning, right? We're going to take each of them and then discuss them one by one. After that, we will move on to the supervised machine learning, and then we discuss them one by one. Each of them that we discuss, we're actually going to go to the lab and then see how things work at the lab. Okay, so as I said, the next class, right, the next class over here, we talk about regression. Okay, the next class we talk about regression, and we're going to start with linear regression, then we progress to logistic regression. Okay, so see you in the next class. Have a nice day.